Welcome back to the Dargslan series. This is part 17, and it's where things start to get really fun. Up to now, we've been typing commands one at a time, but today we cross the line from casual shell user to actual scripter. We'll cover variables, conditionals, loops, and functions, the building blocks that turn your favorite one-liners into real, reusable scripts. So go ahead and open up that editor. Let's write some code. Here's the roadmap for the next hour or so. We'll start with what actually makes a file a shell script. The shebang, the permissions, the basics. Then we'll move into variables and quoting, which honestly will save you from most of the bugs you'd otherwise write. After that, reading input, making decisions with if and then, looping over things, and finally wrapping repeated logic into functions, because nobody wants to maintain a 400-line hairball. So let's start at the beginning. What actually turns a plain text file into something Linux will run as a script? 3 ingredients. First, the shebang, that nar bin bash on line 1, which tells the kernel which interpreter to hand the file to. Second, the executable bit, set with command plex. Without it, the shebang alone won't save you. And third, you actually invoke it. Chuck script.sh from the current directory, or by name if it lives somewhere on your path. That's the whole contract. With that contract in place, our scripts need a way to remember things. And that's variables. Assignment is just name equals value, with no spaces around the equal sign. Bash is strict about that. To read the value back, you prefix it with a $sign. Quoting matters too. Double quotes expand your variables. Single quotes treat everything literally. And that syntax is command substitution. It runs the command and drops its output right into your variable, which is how today ends up holding the current date. And since we just touched on quoting, let's make it a rule. Quote your variables always. Double quotes are your everyday choice. Variables still expand, but spaces inside the value stay intact. Single quotes are purely literal, perfect when you want a $sign to just be a $sign. And leaving a variable bare? That's how a file name like mynotes.txt becomes 2 arguments, and an rm command quietly deletes the wrong thing. Now, a script that can't take input is just a fancy alias, so let's fix that. Scripts pull data in 2 main ways. Positional arguments, that's $1, $2, and friends, with $, giving you all of them and $, the count. Or interactively, by asking the user with read. The P flag lets you tack the prompt right onto the read call, and whatever the user types lands in the variable you named. 2 simple mechanisms, and between them they cover most of what you'll ever need. Once your script can take input, the next question is what to do with it. And that's where conditionals come in. In Bash, you branch with if, wrap your test in double square brackets, and close the whole block with phi. That's just if spelled backwards, which is Bash's little joke. Use double brackets for file checks and string comparisons, and double parentheses when you're doing actual arithmetic, like checking whether count is greater than 10. Add an else for the fallback path, and you've got real decision-making. So what actually goes inside those brackets? For files, you've got -f to check a regular file exists, -d for directories, -e for anything at all, and -r to confirm it's readable. For strings, -z catches empties, -n catches non-empties, and double equals or bang equals compare values. And for numbers, you drop into double parentheses and use the math symbols you'd expect. Equals, less than, greater than, and so on. Memorize a handful of these and you can express almost any condition you'll need. Now that you can ask questions, let's make the shell do work in bulk. The for loop walks through any list you hand it. Files matching a glob, a fixed set of names, or a numeric range with brace expansion. So whether you're processing every log file in a directory, creating a batch of users, or just repeating something 5 times, the pattern is the same. For, in, do, done. Master this one construct and a huge category of repetitive work disappears. While loops are for the times when you don't know upfront how many trips through you'll need. The classic example is reading a file line by line. That first snippet pulls each line from input.txt until there's nothing left, with IFS cleared and read. R, so whitespace and backslashes survive intact. The second pattern is the counter version. Keep going while I is less than 5, bumping it each pass. Same keyword, 2 very different jobs. Once you find yourself writing the same few lines twice, it's time for a function. Define it once with a name and a pair of braces, then call it like any other command. Inside the function, $1 and $2 refer to the function's own arguments, not the script's. And using local keeps variables from leaking out. And since functions return an exit code, you can chain them with and just like is root here, which quietly checks EUID and only echoes if you're really root. So let's pull all of these threads together into something you might actually run. This little backup script grabs a source and destination from its arguments, defines a tiny log function that timestamps every message, and then guards against the obvious mistake, a missing source directory, by bailing out with an error. If we get past that check, our sync mirrors the source to the destination, and our log function bookends the whole thing. Variables, arguments, conditionals, functions, all working together in about a dozen lines. Before we wrap up the scripting side of Part 17, let's flag 3 traps that bite almost everyone. First, never put spaces around the equal sign in an assignment. Bash will read it as a command, not a variable. Second, prefer double brackets over single ones. They handle empty values and comparisons far more gracefully. And third, the classic space bug. Always quote your variables, so a file name with a space doesn't blow up your conditional. Make that last one a reflex. Every variable, every time. And to keep all of that in one place, here's your cheat sheet for the building blocks we've covered. Variables assigned with no spaces, read back with quoted $name. Positional arguments from 1, 2 on up, plus the special @ sign for all of them and hash for the count. Conditionals wrapped in if and fee. Yes, that's if spelled backwards. Loops with for and done, and functions defined once and called like any other command. Pin this slide. It's the scaffolding for everything in Part 18. Before we wrap, let's distill Part 17 down to 5 things worth remembering. A script needs a shebang, the executable bit, and a path to run it. Quote your variables, always. It kills the biggest class of shell bugs. Prefer double bracket tests and double parent math. They handle edge cases the old single brackets stumble on. Use for when you have a list, while read when you're streaming. And once you cross 30 lines or so, reach for functions and local variables to keep the whole thing sane. And that brings us to the end of Part 17. Up next, we push these scripts toward production. Set, UO pipe fail, proper error handling, traps for cleanup, and dry run flags so your automation doesn't nuke the wrong directory at 3 in the morning. 17 down, 7 to go. See you in Part 18.